All right, so this might run over a few minutes today, guys. We have two speakers, so but make sure you all stay till the end. We'll have a poll at the end. It's just four questions, but I need to do that in order to get you guys your PDH certificate. So stay till the end, and we'll have questions. We can answer questions at the end as well, or the chat box should be open. So if you guys have any questions, feel free to pop those in the chat box. I'll be monitoring that as we move along here. So this is our first urban chat of the year for our 2024 urban chat series, slope stabilization. So thank you all for attending. This urban chat and all of our past urban chats are recorded and they're uploaded on our YouTube channel. So you can find those past urban chats, and this one will be uploaded in a few days. YouTube.com/@ Warren County SWCD. So you'll see there in that screenshot runoff reduction methods. We had that one last year. So I wanted to point to Ohio's Rainwater and Land Development Manual. That's where you could find all of the design criteria and specifications for all the different BMP measures, for soil erosion control measures out on construction sites. So you could navigate to their website. There's the link there. The guides and manuals page, they have a bunch there. So you'll scroll down, you'll see rainwater and land development. You'll click on that. The things we'll be talking about today are covered in Chapter 7 on soil stabilization practices. And even in more detail on that, highlighted at the bottom, we have our rolled erosion control products. So you have your temporary erosion control products, turf reinforcement matting, that's your permanent rolled erosion control products, which I believe we'll mostly be focusing on the permanent ones today, which are all approved by Ohio EPA. Just make sure that they're installed properly. That's the common failure that these have, is if they don't have that contact with the soil and the water just, goes underneath the mat rather than over it. So temporary, permanent, the top picture, you have straw matting. It's biodegradable. It breaks down in a year or two. There might actually be some loose straw on the banks there. Looks like we have a channel there that some erosion where maybe the loose straw had washed away. Maybe that would be a better case for a more permanent rolled erosion control product until the vegetation gets established. So on the bottom there, you'll see that green kind of material. Great for areas of concentrated flow, slopes with high erosion potential, areas where vegetation alone is not sufficient. But we do need those to be UV resistant so that they don't break down under the sunlight and introduce microplastics into the waterways. But these products that Tim and Andy were talking about, they have UV resistance to them, I do believe. So at that point, I think it's a good point, good segue here to turn it over to Timothy Lancaster.
Yeah, you can call me Tim.
Tim, okay. We'll turn it over to Tim. Got a bio here, want to read first. So Tim Lancaster has been involved in the erosion control industry for over 30 years. After graduating from Purdue University in 1988 with a bachelor's degree in natural resource and environmental science, Tim worked for North American Green in various erosion technology, product development, and managerial roles until 2017. During his time with North American Green, he invented and further developed the company's line of VMAX composite turf reinforcement mats. From 2004 to 2014, Tim served as chairman of the Erosion Control Technology Council, ECTC, an industry organization that develops and promotes standards and guidelines for various types of commercially available erosion control products. Since 2017, he has been inventing, developing, and launching a new line of simulated turf erosion control products with improved erosion protection capabilities. Tim now serves as Vice President of Sales for Grassworks LLC, the manufacturer of these innovative new products. So thank you for being here today, Tim. And
Great. Thanks, Justin.
you're welcome. You should be able to take the screen away from me, share your screen.
It says I cannot share screen while other participant is sharing.
Okay, just stop
Okay.
sharing. Try that now.
Okay, are you seeing my screen?
Looks great.
Perfect. All right. Well, thanks again for having me, Justin. I appreciate it. Uh, you said my name's Tim Lancaster. I'm with Grassworks Institute. We are a St. Louis-based manufacturer. Actually, been in St. Louis for about 50 years now, making AstroTurf-based products for a variety of industries. I came to the company back in 2017 after I left my former company. And at that point, we were bought by a competitor. And when I left the company, I actually started doing some product development work on my own, doing a lot of backyard research, if you will, on various product concepts that I had. And one of the issues I was trying to resolve back then is with permanent turf reinforcement mats, until they become vegetated, they just don't provide a super high level of erosion protection. So I was looking for a way, or actually trying to develop a product that would provide a much better erosion protection from day one of installation. So I had an idea in my head at the time that if I had a product that actually looked like grass, then it might actually provide erosion protection like grass right out of the gate. Kind of a crazy idea. So I started developing different product prototypes, and I was actually in a Menard store one day and just looking around, and I found this plastic grass doormat on the shelf. It was green, looked like grass. And I thought, something like this with some modification could actually work for the type of product I'm trying to develop. So, company's name is Grassworks, based in St. Louis, Missouri. Contacted the company, and they were interested in developing or working to develop an erosion control product, and away we went in product development. So that's kind of where it all started back in 2017. Then we actually launched the products, formally launched the products into the market in 2019. Yeah, if I can get my thing to, here we go. So I think of these products as a hybrid turf instant armor mats. That's kind of the way we refer to them in a generic sense. But these are the really first soft armor type products, roll erosion control products that really give you immediate erosion protection that's similar to very large rock riprap. They're 3 to 4 times more effective than your conventional TRMs right out of the gate. And I kind of think of them as a hybrid vegetative armoring system. So you've got the simulated turf that provides the immediate erosion protection and then helps to establish vegetation and then stays in place to permanently reinforce the vegetation that's growing up through it. So the way the product's used, you're putting seed down first, and then the natural vegetation actually grows up through the simulated turf. The product comes in roll form. It's also a rolled erosion control product, very similar to a conventional TRM or an erosion control blanket. And the product is made from a UV stabilized polyethylene resin. So that resin's molded into we call it a monolithic structure. So it's just one piece of turf there. And then on the bottom side of the turf is a very light geotextile fabric. And that fabric took us some time to develop because it actually had to be open enough to allow vegetation to come up through it. So little seedlings have to emerge up through that fabric, but at the same time be closed enough to provide some filtration properties and help hold the soil in place beneath the turf under flow conditions. So this product comes in either a 3 foot wide or 6 foot wide roll. The 45 feet long, 3 foot rolls weigh about 50 pounds a piece, whereas the 6 footers will weigh around 100 pounds. And then, of course, the product's installed over a seeded area. So you're putting seed down first. Then you're going to anchor the material down over the seed with typically a minimum 8-inch wire staple. Sometimes a 12-inch fabric pin may be used, or even rebar. depending on the type of soil you're anchoring into. And then the nice thing is, once this vegetates, you can simply mow right over the top of it to maintain the vegetation, if you desire to maintain the vegetation. Testing that's been done on the product so far has primarily been for channel lining applications. In channel lining application testing is normally done in our industry using the ASTM D6460 large scale channel protocol. And this particular protocol is used by basically every manufacturer of roller erosion control products. It's used in the AASHTO NetPEP program. And with this particular test, they're measuring soil loss versus applied shear stress in a large scale channel. And their idea of a large scale channel is a 2-foot wide channel that's 40 feet long. When we did our test on our product, on the shear force product, actually ran on a 20% gradient to develop some pretty high velocities and shear stresses. And if you compare the results of this product versus conventional TRMs, as well as a tied concrete block mat, in this graph, we're looking at soil loss versus shear stress. And in the ASTM protocol, a half-inch of soil loss is considered failure. So once your material loses an average of a half-inch of soil from the bed of that channel under the 4 separate flow events that are run on it, it's considered failed, and that becomes your permissible shear stress or permissible velocity for the material. Here we're looking at the 3 graph lines to the left there. Those are kind of your conventional turf reinforcement mats. You'll see that all 3 of those products from an erosion control standpoint perform about the same. They're all at or approaching that half-inch failure point between 2 and 3 pounds per square foot of applied shear stress. Bear in mind, these are unvegetated materials at this point. Move to the right there, the yellow line is a tied concrete block mat, and then the green line is the Shear Force 10 Instant Armor mat. So you see the Shear Force 10 perform pretty close to or very similar to a tied concrete block mat through this test. The product was run up to between 11 and 12 pounds per square foot of shear stress, and it did not fail. Soil loss under the product, from under the product, up to 11 to 12 pounds of shear was only 0.2 tenths of an inch versus the half-inch failure point. So the product didn't actually fail through this test. We've actually backed that testing up with some bench scale testing here recently. We had submitted the product to the AASHTO, National Transportation Product Evaluation Program. And I don't know if y'all are familiar with this program or not, but it's a pure third-party testing program, and they run this for an AASHTO program. It's run basically for DOTs to use for developing product APLs as well as maintaining those APLs. And they don't just do it for erosion products. It's basically all transportation related products, from signs to pavement to you name it, pipe. But through the NetPEP program, we had the product tested. And within this program, they use a bench scale test for shear stress. And it's the ASTM D7207. And here, once again, they're measuring soil loss at various levels of applied shear stress. And in this test, their soil loss failure point, once again, is a half-inch. They measured that in weight. 450 grams of soil is considered a half-inch of soil loss. And you'll see the collection of TRMs and HP TRMs, high-performance TRMs to the left there. Those are 8 different products that they had tested. I think they probably tested a total of maybe a dozen permanent materials. And you'll see that all those products failed this test between 2 and approaching 5 pounds per square foot of shear. Most of the products between 2 and 4 pounds of shear stress. Move to the right, you'll see the Shear Force 10. Actually, the final test flow on this product was at about 5.4 pounds per square foot of shear, and the product only allowed 62 grams of soil loss. So way under the 450 gram of soil loss failure point. And if you extrapolate that out to a failure point, it'd be around 13 pounds per square foot would be the permissible shear on the product, which would be not hard to believe considering how well the product did in the large scale testing without failure. So when you're looking at using a permanent roll erosion control product, you're normally looking at using that in place of something hard like riprap or even concrete-based materials. So, of course, using these roll erosion control products, you are establishing vegetation. They allow you to use vegetation in place of hard armor in areas where you normally couldn't do that. So the benefit of using vegetation are many, from an environmental standpoint, water filtration, aesthetics, site usability, as well as cost. And cost is often the deciding factor on what gets used on a job. And with using a shear force 10 type product, the costs are usually 50% or less than that of using either rock or concrete. Something else I like to point out too is that if you have a site that you have access issues in, trying to get products in there or materials in, or it's back in a development area, or you have to haul materials to residential developments, commercials, or commercial developments, or neighborhoods. You don't want all those dump trucks rolling through there, slinging mud all over the streets and having neighbors complain about the traffic, the noise. One semi-load of this product is about 26,000 square feet of material, and that would replace approximately 300 dump truck loads, 14-ton dump truck loads of 24-inch rock. So it's much more transportable. It's a lot easier to transport and offload, and certainly place on a job site without all the heavy equipment and truck traffic. Typical applications, of course, going to be high flow channels, drainage swales, steep slopes where you do have excess runoff coming from above the slope, say a slope along a parking lot where you've got water sheeting off of a parking lot. A lot of slope applications can actually be protected sufficiently with a degradable erosion blanket or maybe even a hydromulch. But if you have a lot of runoff coming from above the slope, you may need a permanent product like this. Or if you have a slope that's very steep and long, that's going to generate a lot of erosion potential on the slope, you may need a permanent product like this as well. Products also used in culvert outfalls, steep down chutes, for pond and lake shoreline protection, and also areas where you may just not get real good vegetation growth, whether that's because of a lot of shade in the area, very dry area, or just really poor soils. This product can provide that supplemental erosion protection around whatever vegetation you do get growing in that area. This is a steep slope application that we done with a product a couple years ago, and this was out in Fort Leavenworth, Kansas, on the base out there. This is a 100-meter target range, and when they built this range back in 2019, they cut this slope back. It's about 2-to-1 in many areas, very steep, up to 200 feet long from top to toe, and when they did this installation or project, I think they may have just like sprayed some hydromulch and seed onto the face of the slope, walked away from it. And 2 years later, they just had a lot of erosion, a lot of rilling. A few pretty good sized gullies had formed. And I guess 2 years ago, they were having a general that was going to visit the site late that fall, and they said they had to get it cleaned up. So they put quite a bit of money into actually renovating this slope, but they actually came in and basically regraded that slope, put a layer of 8-inch topsoil down, compacted it, and then smoothed it out really nicely. I was surprised at how well they got, how smooth they got the surface of this slope, which was great for installation because this is the way it should be done in most applications. The smoother that soil is, the easier it is to install the product properly and get that good mat to soil contact, which is really needed for these products to work the way you want them to. But they basically hydroseeded the slope, used a native grass mix, installed the shear force 10 over the top of that. It's kind of a little before and after here. The picture to the right was not quite after. They weren't quite done with the installation yet, but you can see the green, the material on the slope face there look really nice. And then 3 weeks after installation, they had grass popping up through it. I will say one thing, they did water a lot of this slope because it was done in early August. Of course, early August, one of the driest times of the year. So they did actually water this slope, and they got grass to pop up through the mat pretty quickly and got it to start greening up just in time for the general to get there, I guess. But this is one of the early applications we did with a product, kind of a trial application we did with Peabody Coal Company, actually. And this was done on one of their overburden caps. You see off to the right there, and this is a perimeter swell along that overburden cap. It's about a 25-acre cap. And we came in and installed the shear force 10 between a couple of the check dams they had in this perimeter swell. And it's a pretty steep channel at probably upwards of 10% down towards the end of it. But where we did our installations, probably in the 4 to 5% gradient range. But did the install, left a couple of control areas downstream and just kind of upstream from the test section there. Just those areas were just seeded and straw mulched, just kind of see what would happen in those areas without protection. This picture was taken day of installation, looking downslope or down the channel gradient. And this picture was taken about a month later. Hardly any rainfall during that month, so no seed germination to speak of at that point. And then 2 weeks after installation, that's when all the rain started. And late October of that year, on the 21st, over 1.5 inches of rain. And then just a week later, over 2 inches of rain. And I actually went out to that site in late November to see how things were holding up. And the first thing I saw was what you're seeing to the left there is several large gullies had formed in the overburden cap. And then the center picture was taken of the check dam just upstream from our test section. You can see some of the rocks had washed out of that check dam at that point. And then the picture to the right was the just downstream from our test section, and you can see some of the rocks had washed out of the check dam in that area as well. Our test section looked like this nice green rectangular swath of grass, kind of in a sea of brown, rilled out side slopes here. Just a lot of erosion around the test section, a lot of grass just in the area that was protected with the matting. And then you can see that control area just downstream, a nice scour hole formed just at the end of the test section, and it's probably 20 to 24 inches deep at that point. So pretty serious scour in that area. Kind of a close up of that. Here, you can see the scour hole, and then right along what would be the right side slope of this, we're looking upstream here, up the channel gradient. A lot of the scour had occurred right along the edge of the matting. This is 8 to 10 inches deep, 3 to 4 feet wide. Just a lot of soil loss right where the mat stopped. And it's kind of cool because I'd never seen anything like this before. And at that point, 28 years in the industry. But vegetation, the grass actually grew right out to the edge of the matting. And there was just enough soil kind of clinging to the roots below the matting to sustain the vegetation growth out there. In the following spring and that April, they came in and filled that scour area along the side of the matting. They filled that, compacted it, seeded it, straw mulched it, thought it was good. And then by the end of May that year, they had enough rainfall that all their fill soil washed out. And at that point, they had several rocks wash into that area that had scoured out previously. So this channel carried a lot more water than what we expected it would. And you can even see the condition of the check dam downstream there. On May 1, a lot of the rocks had washed out, and just a lot of channel erosion down from that. And then by the end of May, that check dam had pretty much been leveled. That thing was just darn near flat at that point. So a lot of uses in commercial and residential development, drainage channels. This was an application down in San Antonio, Texas, went in the end of June a couple years ago, and I guess almost 3 years ago now. But a situation where they did not want to use rock. It was in a condominium complex, and so they're looking for a vegetative alternative to rock. They went with the Shear Force 10, put it down, and then within about a week and a half after installation, actually had a 7-inch rainfall event on this site. It's kind of crazy for San Antonio that time of year, but just a major storm event, dumped a lot of water in that area. The channel itself probably reached about 3/4 capacity with flow. And then the picture to the right was taken last spring in May, about 2 years after installation. See all the good vegetation growth in the area at that point. Stream bank stabilization's another good application for the product. This is a stream bank that we did kind of early on as well on a Peabody coal mine site, in a situation where it was going in late October, so they knew it'd be the following spring before they got good vegetation growth. So they were looking for something to armor the banks and really kind of hold them in place until vegetation could take hold the following spring. And it's good they did, because that winter in particular, they had hardly any snowfall in that area, but they had a lot of rain. They kept getting these 2-inch storms coming December, January, and February. Every time that would happen, that little stream channel would flood out. And then you can see in the picture to the right there, really good vegetation growth right along the bank where the matting was used. And see some real distinct lines at the toe there, and that's right where the matting stops. So it's kind of like right where the matting stops is where the vegetation stops. Pond and lake bank applications, I think, is a great application for this type of product in place of rock, because all these commercial residential developments, they all have detention ponds, and a lot of these ponds are eventually used for recreational purposes. And this particular application here was actually specified, the engineer had specified using rock on this dam face, and the contractor proposed using our product instead of rock, primarily because of accessibility issues. So only way to get down to this dam was a golf cart path, and to haul rock down there would have been one bucket load at a time on a bobcat. It was just going to take them forever to do. So they could haul our material down there, and this pond's used for fishing. You can't see it, but there's a lot of older homes around this lake, and by using a vegetative option instead of rock, it was just going to be much more user friendly. And they did this with a native grass mix as well. A native grass mix, probably some riparian stuff in there too. You can see some sedges growing through the mat at that point. And this thing vegetated pretty quickly. It went in May 1st, and the pictures to the right there were taken the end of July that same year. So it vegetated pretty quickly, especially considering they use a native mix, which sometimes take longer to develop. We do a lot with solar farms with this product, from drip line protection to draining swales, especially if your drip lines or your arrays are on sloping areas. A lot of times they have erosion issues right under the drip lines. And of course, if the arrays are out in a flat cornfield or something like that, there's probably not much of an issue there. You probably don't need a permanent product like this, but if they're mounted on sloping areas, which is becoming a lot more common due to land prices, this type of product might be needed along the strip lines. But and then of course drainage swells and channels running through these sites. You know, a lot of these solar farms are several thousand acres in size, and they all have drainage issues to contend with. Just a couple more things. Product installation. I know Justin mentioned installation is key to these products working properly. And I'd just like to make a couple points on installation. And one of the points is to make sure you get the product flush with the soil. It needs to be in contact with the soil in order to work the way you want it to work. So the product's not touching the soil, something holding it off the soil itself, then it's not going to do what you want it to do. And one of the ways to get that is good soil preparation. So the smoother you can get the soil to start out with, the easier it is to get the mat up against the soil when you install it and keep it there. And then also using the proper anchors and staple pattern depending on the flow conditions and the type of soil you're anchoring into. So you want to get the product against the soil and you want to keep it there. And then you also want to keep water flow on top of the mat, which typically means trenching in the edges, making sure whatever water is coming from around the area is going to flow over the top of the mat and not undercut it or start rilling soil above it or around the mat, and that rill undercuts the mat along the edges. And also securing the seams between adjacent rolls and material. And one thing with this particular product, we've got kind of a built-in overlap edge we call a seam lock edge, where one edge of the mat is flat, it's inset 2 to 3 inches, and then the other edge of the roll is full turf with no fabric. And when you're adjoining or basically seaming 2 rolls side by side, you're overlapping that full turf onto that flat edge, and it makes for a really nice flat seam, nice secure seam between rolls. And that same overlap edge is actually on the terminal ends of the rolls too. So when you're overlapping rolls, you know, end over end, it kind of gives you that same nice flat seam. And with that, I'll take some, I don't know if we're doing questions right now, Justin, or not, but if you have any questions, I'll be glad to take those now. We do sell the product in Ohio through our distributor, Meredith Brothers. They're located in Reynoldsburg. And I've got their phone number, if you're not familiar with them, on the screen there, as well as their web address. So you can get more information, products from them, or you can also reach out to me directly. So thank you.
Yeah, we could certainly take questions now if anyone has anything. Unmute yourself or put it in the chat box. I don't see anything in the chat box yet. But I maybe have a question for you, Tim.
Uh-huh.
I did have a question here from one of our local watershed networks along the Little Miami River here, and they were asking how these products would work to help stabilize stream banks. I saw some of your pictures. It looks like they actually do a pretty good job of that. But yeah, they're just wondering how these would work along stream banks. They're thinking of doing some projects on stream bank restoration along the Little Miami River.
Sure.
There have been some matting products used before, but yeah, I did see that it allows the riparian vegetation to grow up. Does it allow for like trees to grow up through it too, through that shear force 10?
Yeah, a tree would come up through that. You know, like a tree seedling would certainly come up through it. And a lot
Okay.
of times, you know, eventually you may actually have that type of vegetation growing on top of the mat, because what I've seen in a lot of situations where like stream banks is a lot of sediment load. If you have bed load and sediment, it will get trapped in the turf, and over time will kind of build up on top of that. So eventually down the road, you may have vegetation growing on top of the mat, rooted down through it.
Okay.
So, and for stream bank applications, yeah, it can work very well. What we would normally do is look at the expected flow in the stream and kind of look at that as a large drainage channel, so we can calculate velocities and shear stresses and really give you a better idea of whether the product's going to be suitable for the application. Most smaller streams, I will tell you, it should be. Most streams, especially in your area, probably aren't on really steep gradients, which steeper the gradient, as you would know, higher velocity, higher shear stress. But we can always take that information and really give you a good idea of whether the product would work or not.
Cool, thank you.
Right. Well, thanks again for having me.
Yep. I'm not seeing any other questions in the moment, so if you guys have anything else, feel free to enter in the chat box. Okay, Jordan Weber has a question. This product is fully approved for use with Warren County, I'm assuming. Or have any issues with neighboring counties? Yeah, the Ohio Rainwater Land Development Manual does allow for permanent road erosion control products, and having the UV resistance built into it, I think that's a huge plus for that. So as far as I'm aware, this product would be approved for Warren County. Have not heard of any neighboring counties if any issues with the product or if they've used it or not.
Yeah, and we have a couple of things on top of that. We have on one project gotten it approved by the DNR. So Department of Natural Resources has approved its use. And then we are on the verge of getting ODOT approval. They basically have approved it, but they are working to develop a new category for the product on their APL. So they recognize that the product really doesn't fit in the same category as their TRMs, and it's quite a bit physically different than the Tide concrete block mats. So they are looking at creating a category basically for this product that would fit.
Okay, Vic Meredith has just replied. We have an installation in Warren County for ODOT. Todd says, what are the slope limitations for this product?
Really, the product could be used down to a 1-to-1 slope. It really, the limitation is going to be based on the internal stability of the slope itself. So this product's not going to prevent slumping. It's not going to prevent veneer stability issue or failures. I think Andy's probably going to talk about a product that will do that. But if it's a superficial erosion protection type of situation, this product will work on a 1-to-1 slope or maybe even steeper. So as long as the product's not going to slough or slump, or the slope's not going to slump or slough, and you're just trying to prevent that superficial erosion, then this product would work fine.
Great. Thank you, Tim. We're going to move on here. If you guys have any more questions, feel free to pop them in and we could maybe address them at the end if we have time. So if you could stop sharing your screen, thank you. So we'll queue up Andy Durham here. Andy Durham is the North Region Sales Director for Western Green, the largest manufacturer of rolled erosion and sediment control products in the United States. Andy came from a 14-year background in civil engineering and entered the erosion control industry in 2011. Since then, Andy has had roles in applications engineering, technical sales, and marketing for various geosynthetic and erosion control companies, focusing on innovative engineered solutions for infrastructure construction. Andy still maintains his professional engineering license in Florida and currently resides in Granville, Ohio. So thank you for being here today, Andy. And you could go ahead and take it away.
Thanks, Justin. You can hear me okay?
Sound great.
All right, good. So today I'm going to talk about Western Green, my company, and the products and solutions that we have specifically for slope stabilization. We'll talk a little bit about erosion control and the products that we do for that, but I want to focus a little bit more today on slope stability as part of this Urban Chat webinar. Just a little bit of background on Western Green. We're the amalgamation of 3 companies. Previously, we were Western Excelsior, and then in 2017 acquired North American Green, and then in 2021 acquired East Coast Erosion Control. So now we have 6 facilities across the country two in Indiana, one in Pennsylvania, Macon, Georgia, Lake City, South Carolina, and McPherson, Kansas. And what that means is that we've got the ability for a lot of speed to market. We can get product on the ground quickly to all areas of the country because we've got such a diverse geographical base that we can ship from. So we are the largest manufacturer of rolled erosion control products in the country, probably in the world, and we sell through distributors all throughout the United States. So that's a little bit of information about Western Green. Want to talk about erosion and then a little bit about slope instability. So keep in mind that erosion is the transport of soil particles that are detached by water or maybe wind. Sedimentation is the deposition of those soils. So it's a cause and effect, transport and then deposition. And that's what the definition of erosion is. You could have a slope instability, a slumping, and Tim just talked about internal stability. You may not have erosion and could still possibly have a slope failure. Now, not to say that erosion wouldn't contribute to that, but there is a difference between internal stability of a constructed or natural occurring slope versus the erosion of that slope. So we're not talking about transport of particles in sedimentation anymore. We're talking about mass chunks of failure of earth. And so that's what that's the main difference between slope instability and soil erosion. What are some of the causes of slope instability? And erosion could be one of those, but really increased shear stress on the soil and decreased shear strength of the soil is going to result in a potential failure. And a lot of times it happens with oversteepening of slopes or removing some of the stabilizing mass of soil. Increased loading, erosion of seepage, saturation, poor water pressure changes, vibratory action. There's a lot of things that can contribute to slope failure and slope instability. And just want to be cognizant of what those are when you're looking at evaluating or designing something on a steep slope. There's really two different kinds of slope failures. A translational failure is more of a sliding superficial failure. We call it an infinite slope because it really doesn't have a defined beginning or end to its slide. And then if you see, when you're driving down the highway and it looks like somebody took a giant ice cream scoop and scooped out the side of a hill, that can be a rotational failure. That's more of a deeper seated failure. It's driven more by, more clay soil, and they can be a little bit nastier than a superficial sliding type of slope failure. As far as reinforcement strategies goes for slope instability, and like I said, this is beyond erosion control. Retaining walls are certainly a pretty popular one, as are mechanically stabilized earth, where we're actually reinforcing the slope by tying back different fabric or geogrid materials. Soil nailing, deep soil nailing can be a method of slope stability or slope reinforcement. You could terrace the slope, change its geometry, or you could buttress it and replace some of that mass back that actually stabilizes the slide against the sliding force. But at Western Green, we have a product or a system. We call it the Turf Earth Reinforcement Mat System. And what it consists of is our high performance turf reinforcement mat coupled with our percussion driven anchors. And if we can determine where that failure surface is, whether it's a sliding failure or rotational failure, and we can feasibly get our anchors, our percussion driven anchors beyond that failure plane, then we can actually mitigate against slope instability. And then we're solving a problem beyond just soil erosion. So with that said, I wanted to go a little bit into some of the products that we sell. Now, some of these would be for slope protection and erosion, but others would go into more of the slope stability applications. We manufacture rolled erosion control products, and Justin talked a little bit about those at the beginning of the presentation. Some are temporary, some are long-term, many are biodegradable. And then we move into turf reinforcement mats. Turf reinforcement mats that are used for erosion, channel erosion, and Tim talked about that. And then we also do sediment retention rolls. I'm not going to go into those today, and we'll talk a little bit about fasteners. But we've got a whole realm of products in our product portfolio throughout the Western Green brand and all of our brands. So let's talk a little bit about rolled erosion control products. And these are your straw and coconut blankets. These are good for shallower slopes. We're not addressing any kind of, internal stability or global stability with these. But really with these products, what we're intending to do is to give the vegetation an opportunity to get started. We're protecting the vegetation as it's emerging, protecting it from rain splash or shallow flow or even birds. But we're not doing anything more than just a temporary protection or covering with an erosion control product. So we make several. We make double net and single net straw, coconut blends. We also provide our products with all natural biodegradable materials. So when you think low slopes, shallow slopes, no internal issues with potential failure, then a rolled erosion control product, an erosion control blanket can be a good solution. Moving on to turf reinforcement mats. Now, every turf reinforcement mat is a rolled erosion control product, but not every rolled erosion control product is a turf reinforcement mat. Turf reinforcement mats are special because they are permanent materials. And what they're designed to do is lock up the roots and stems of vegetation while it's growing to provide more hydraulic resistance than that vegetation would be able to provide by itself. So if you think about grass being concrete, then turf reinforcement mats would be the reinforcing steel to that concrete is a good analogy. But ideally, we'd want the grass to grow fully through these turf reinforcement mats, get full vegetation, add a lot of performance for erosion control, and maybe not even know that they're there over time. So that's the intention of a turf reinforcement mat. We do several different turf reinforcement mats at Western Green, including the VMAX products, which actually have a combination of natural fiber infill and permanent erosion control protection with netting. And we do this in synthetic versions as well. These are for extreme flows and channels and steeper gradient slopes, but we're still not addressing the internal slope stability with these products. We move on to high performance turf reinforcement mats. High performance turf reinforcement mats are special. They're designated as high performance for one of two reasons, or for two reasons, or two ways. One of it is the tensile strength. So we have 3,000 pounds of tensile strength minimum in both directions in a high performance turf reinforcement mat. That's compared to a couple 100 pounds in a rolled erosion control product. And then we also have extreme UV stability. We can have these products on the ground for 25 years plus, sometimes even 50 years without solar degradation. So two big criteria for high performance turf reinforcement mats that are above and beyond regular turf reinforcement mats. Why, may you ask, that we make high performance turf reinforcement mats with so much strength and so much UV resistance or longevity? It's because it's for all the things you can't design for in your hydraulic calculations. And that might be burrowing or trampling wildlife, debris like shopping carts or pallets, and even batwing mowers. So all these things that can damage a standard rolled erosion control product or a standard turf reinforcement mat. That's why we make the high performance turf reinforcement mats, is to mitigate against these non-hydraulic stresses. And then grouping in, well, before we go into that, we treat high performance turf reinforcement mats like geosynthetics because they are geosynthetics. And so we'll do all kinds of engineering testing, including thickness, mass per unit area, tensile strength and elongation, and all the hydraulic resistance. And Tim mentioned some about the hydraulic flume testing or large scale flume testing that we do with these products as well. We make two different types of turf reinforcement mats. One is called a PP5 Extreme. The other is called PMAX. There's some subtle nuances between the two products, but they both are considered high performance turf reinforcement mats with a high strength and high longevity survivability. I want to talk about the anchor as the chief fastener that we use with a high performance turf reinforcement mat. And this anchor, we call it a percussion driven anchor. I've got one in my hand here, but basically it comes in three parts. It's got a top termination cap with a grip on it. It's got a cable tendon, and it's got an anchor head or anchor foot at the bottom. Now, this anchor head that I have in my hand is actually the smallest one that we sell. We actually go to a much larger one depending on what we need to use it in terms of applications. So essentially, we're driving the anchor into the ground using a piece of drive steel, and it's got that flexible cable tendon. Once the drive steel is in the ground, we pull it out, and then we tension the cable on the earth anchor. And by tensioning that cable, it'll actually turn the anchor foot in the grade so that it becomes parallel with the surface of the slope. And once you do that, you're radiating an entire cone of soil resistance that's deep seated into the ground below, where you might have the veneered high performance turf reinforcement mat on the top. So this is going back to our turf earth reinforcement mat system, which includes the high performance turf reinforcement mat and the percussion driven anchor. And so if we can, like I said, if we can determine where that slope plane of slope failure is occurring, whether it's translational or rotational, then we can design a pattern of anchors. And when I say a pattern of anchors, you can design the number of anchors, the spacing of the anchors, and the embedment depth of the anchors, along with their size, so that that they can provide more pull-out resistance. And if we can get that anchor pattern correct with the high-performance turf reinforcement mat veneer, then we can design the factors of safety against sliding or translational slope failure. A 1.0 factor of safety is basically an impending failure, a 50% chance of failure. So we're trying to get way beyond 1.0 and up into the 1.3, 1.4, or 1.5 measures of factor of safety for our designs with these systems. So I'm going to give you an example of where we actually used this system for a slope stabilization application. And again, when you look at these pictures and you look at some of these things, think about how this transcended general erosion and really was into a slope reinforcement type of application. So this is a project that we did near Cleveland on the Chagrin River in a little town called Moreland Hills. And it's a subdivision, residential subdivision, with some high-end lots. And the very last lot that they built on had a pretty steep bluff going from the back lot line down to the river at the edge of it. You can see that in the topo there. This is what slope failure looks like in a natural condition. So as you can see these pictures over here on the right, this is actual frequent landslides or decreased shear strength of the soil, increased shear stress from oversteepening. All the soil is dislodging, sliding in a mass mechanism down and depositing into the river. So bad news. And this had to be reinforced and repaired in order to be able to develop on this lot overlooking the river. So you can see some more pictures after they cleared it. And this is probably a combination of the erosion that started to happen, plus that continuous slope failure as well. So there was a lot of issues with the slope being too steep to be able to hold itself on itself while they were going in and repairing it and setting it up to create this bluff on the backside of the residential lot. You can see the existing topography here, and it varied from a 1-to-1 to like a 1.5-to-1 as you went down the hill. Their goal, the designer's goal, and that would included the geotechnical engineer, was to do some stabilization at the base of the river. They wanted to flatten this slope from a 1-to-1 / 1.5-to-1 to a 2-to-1. They wanted to revegetate that, and they wanted to get some kind of structural element down at the bottom to provide some global stability so they could address the superficial stability going up to the rest of the property. So this was the proposed design, and you can see they developed some rock groins down at the bottom to stop that river from scouring. They did do a small profile sheet pile retaining wall that was soil nailed in, but then they proposed grading the slope at 2-to-1 from the bottom of this retaining wall all the way up to the held lot line at the back of the property, or the back of the buildable area on that lot. So this is what the slope looked like after they graded it out, ready for it to be stabilized. You can see the retaining wall there at the bottom. They put some poly wrap fabric on it just to protect it. But the big question at this point was, if they graded this slope out to a 2-to-1 with this retaining wall at the bottom and this lot line at the top, would that slope be globally stable or geotechnically stable to keep it from failing more than just what erosion would cause? And the answer was a resounding no. It was not globally stable. It was not geotechnically stable. As a matter of fact, the factor of safety against sliding slope failure was 0.65 in the existing condition. And with our anchor pattern, and I'll show you that in a minute, we got that factor of safety up to 1.3, which was the targeted factor of safety for this slope. So this was all done through geotechnical testing and geotechnical design and modeling. And this is the anchor pattern that we came up with. So we had anchors on 5-foot centers, and then we had these intermediate twist pins every 2.5 feet or 2 feet in some cases. And then we used a 3-foot long cable tendon anchor to get to that design and that anchor pattern. So how are these installed? You might ask. This is the sequence and procedure for stabilizing that slope. This is the graded slope. And they went in and they put a pretty good prepared seed bed, raked it all out, got some good native adaptive vegetation seeded in there. And you can see that before the turf mat goes down. Now you can see the high performance turf reinforcement mat. It comes in rolls. Sometimes they're 8.5 feet long. Sometimes they're 11 feet. Sometimes they're even 15 feet long. But we're basically shingling these rolls across the slope and running them down the slope. And you can see one of the anchors installed right here. Here's a couple more pictures. You can see the earth percussion anchor installed. These guys are driving the steel down into the ground. They actually tethered off of one of these anchors to be able to drive the rest of them when they went down the slope. And then you can see the intermediate pins that were installed down the between the anchors as well. So this is what the slope looked like when it was completely buttoned up. And you can see all the cable tendons that are still sticking out from the anchors that went back and got clipped. You can see the retaining wall down at the bottom. We did some stability below the retaining wall and above the retaining wall. We even had some large root ball trees that were planted in, and we were just able to cut the mat away, put the tree ball in, and then repair the mat in those areas. You can see what that slope looks like. The owner at the last minute, property owner, said that they wanted an access path, a switchback path from the top of his lot down to the river. So we were able to actually incorporate that into the construction as we were going along. This is what the vegetation looks like after immediate growth, and we're talking a couple weeks. So that seed bed that was nicely prepared and irrigated popped pretty quickly through this high performance turf reinforcement mat. This was, like I said, within a couple weeks after it was installed. And then after about a year of installation, we've got a little more than 50% coverage of the total slope. And then if you go 2 years into after installation, you can see that it's fully vegetated, almost 90%. There's the river, there's the retaining wall. And then just last year, I went out and took some pictures of what the slope looks like today or this past summer with all the native and adaptive vegetation. So this is 3 years after we got more than 95% coverage of vegetation through the slope. The slope is globally stabilized or geotechnically stabilized against a sliding slope failure, and we're preventing erosion with this vegetated system on this steep and sloped as well. So that's all the slides that I have, but I'm certainly happy to answer any questions that you guys might have.
Thank you, Andy. That was great.
Thanks.
If anyone has any, you're welcome. If anyone has any questions, feel free to enter that in the chat box. I'm going to bring up a slide here with everyone's email information. Make sure you stick around so I can get the poll ready, so you guys can answer the poll questions. That way we can get you your certificate. So here's a slide. We got our email addresses. If you guys have any other questions, you could feel free to email us those or put it in the chat box while we're still here. I'm going to get this poll put up here. So we got some 4 questions here, name and email address, just some kind of basic questions here so we can get you your certificates.